Hello everyone, how are you? Today we are going to cover chapter 5.4, 2 and 3 force members. I want you to wash your hands frequently and I want you to keep the social distance, which is 6 feet away from the people. There is another options. I strongly recommend you wearing a facial mask so it would help you protect from the virus. Today we have two learning goals. First is recognize two force member or three force members. What is two or three force members? Let's look at the example today. The next goal is to apply equation of equilibrium to solve unknown forces. Why we need to learn the two or three force members? Because it can simplify the problems, so you can solve the problem easily. Basically what we learned is that if we know the three equation, here we have a three equilibrium equation, that is force Fx should be equal to 0, sigma Fy should be equal to 0, sigma moment should be equal to 0. If the number of unknown variables is less than 3, then we can solve the problem easily because we have a 3 equation, 3 unknown, good to solve. How about more than 4 unknowns? Then the equation what we have right now is not good enough. So somehow we have to reduce the unknown forces. Today, we are going to look at how to reduce the unknown forces by identifying two force members or three force members. Here we have a simple example here. There is a point A and a point B. There are some forces. The direction is not important, okay? There are force A acting on the A point. There are force B, which is acting on the point B. So if you remember the last class, we can set the orientations. We can set the orientation, what we wanted to, if we can change the orientation that can help to solve the problem easily, then we can change the orientation. This is a typical. So right hand direction is positive x, upper one is positive y. This is a very typical and the normal case, but this case is also doable. Okay, there is no issues. You can set the orientation. Let me see. So what I wanted to say is, no matter what the direction of the force is, you can decompose these forces x-axis, this is x-axis, so this is bx and what? By. How about this one? This is ay and this is ax. Okay, so we can express the force using x-axis direction force and y-axis direction force. Okay, now I wanted to explain why this one is two force members. So let's look at the moment at point A. Moment at point A. we have four forces are here. Which force is affecting the moment at point A? We have AX, AY, BX, and BY. Which force is affecting on the moment at A? That is BY, right? Because AX and the BX, they are on the line of the actions. That means there is no perpendicular distance to the point A, right? How about AY? AY is acting on the point A, so there is no perpendicular distance. So that means AX, BX, AY does not affect to the moment at point A, only BY. But since moment point A is equal to 0, that means BY is equal to 0. How about the moment at point B? If the moment at B is equal to 0, that means AY is equal to 0. We know that equilibrium equations, sigma fx should be equal to 0. That means AX, BX are the same but opposite direction. We call this is two-force member. There are three conditions must be satisfied. Same magnitude. AX, BX have the same magnitude. Number two, they have opposite directions. Number three, they are on the same line of actions. We call this is collinear. So if these three conditions are satisfied, then AX and BX is equal. It's equal, same magnitude, but opposite directions. When we apply the equation of the equilibrium, and there are many unknown forces. Now, if this is the two force members, then we can reduce the other unknown forces. This is the three force members. What is three force members? There are three forces acting on. They are intersecting on the same point, which is point O. If you see that force 1, force 2, force 3, they are acting on the beam, which is they are all external forces. But if you extend the line of the actions, they are cross at one point. They are acting on the same point, which means this is the three force members. So what I'm trying to say here is that we are talking about the solid, rigid body. And equilibrium equation means this rigid body is stable. There is no motion, there is no movement. Okay, even though there are three forces acting on this beam is stable. So we can apply these three equations right? These three equations must be satisfied. If this rigid body is stable, that means these forces have a xy component. But when you add up all the components, fx and fy, they should be equal to 0. And the moment should be equal to 0. Right? So let's calculate the moment at point O. In this case, sigma moment at point O. What is this? Well, first, there is no perpendicular distances for any forces here, because they are concurrent. They are concurrent. So in this case, there are no perpendicular distance for any forces. We can say that this is concurrent force system because they are intersecting at one point, which is concurrent system. Sigma moment at point O should be 0. So moment at point O is sigma f times perpendicular distance. The perpendicular distance is 0. So there is no moment. This is too easy, right? This is too easy. But what if these two forces, the line of actions, are crossed at a certain point? Let's say this is point O. But these forces are not crossed at point O. How about this one acting like this? This is F3. Then the line of action is not crossed any this point, right? But this one is crossed somewhere here. But we are talking about the point O. Obviously, this one is a perpendicular. Not perpendicular. This one is parallel, right? F2 and F3 are parallel. So that means this is not stable because the moment any point O should not be equal to 0. If this force 1 is parallel, let's delete this one. So this one, and this one are parallel, but still different magnitude, obviously. Then the moment at any point at O can be satisfied. This is equal to 0. It's possible. So there are two conditions for the free force members. Either they are concurrent or they are all parallel. Then we can say this is a free force member. Let me ask you. Determine the support reactions at the pin at point A, B. So there is pin. Point A is pin connected, point B pin connected, and C is also pin connected. How many unknown forces here? As you may remember, if the joint is pin connected, that means we have two support reactions. So point A has two support reactions, point B has two support reactions, point C has two support reactions, right? For the x-axis and y-axis, x-axis, and this one. So we have 6 unknowns. The direction is not that important, okay? When you solve the problem, then you will realize what is the right direction based on the sign of the numbers. If it is a negative sign, then your assumption should be changed to the opposite, okay? So we have 6 unknowns here. How to solve this problem? That's the question. 6 unknowns. We need a 6 equation, okay? We can draw the 2 different free body diagrams. This one is one free body diagram, this is another free body diagram. So here we have 6 unknowns, but free body diagram we have 3 equation for each free body diagram, so we have a totally 6 equations, so it's solvable. Okay, It's solvable. Technically, it's solvable. And you can see that based on the Newton's third law, these guys are the same. Okay? Action, reaction, action, reaction. Then we can solve the problem with the sixth equation, but it takes very long time, as you remember, as you understand. So let's use the two force member system. As you can see that there is a two force members. What is the two force member, guys? This is two force members. Because this object is stable, there is no movement. That means we know that there are force AY and AX. There is CX, CY, but we can draw the line that passes through the point A and C, and we can set the orientation like this way, right? Anyway, we can say that since this is stable, there's no movement, there are forces acting on point A and point C. So we can see that these two forces are the same, have the same magnitude, the opposite direction, on the same line, acting on the same line. And we know the direction based on the dimension of these numbers. So 45 degrees. So since this is the two force members, we know that if we know the FA, then we can definitely identify force C, right? Because it has the same magnitude. How about this force? There should be two unknowns at point B, right? But you know what? This object is actually three force members. If you remember correctly, if we can apply the equilibrium of equations, then this object is stable, and the three force members, there are the hypotheses. Either they are parallel each other or they are concurrent at the same point. So here we have one external forces and another external forces here, another forces. Okay, so they are concurrent at point O. We call this is three force member. So we have two unknowns. We have two unknowns here. We have two unknowns. We have three equations. So we can solve the problem very easily without using six equations. Alright, let's look at an example here. Here we have a given 4 kilonewton, which is downward direction at point B, and the beam is supported by pin at A, C. I guess D is also pin connected. find the support reactions at A and C. A and C. Okay. So here is our plan. First, so we have to decide the orientation first, and then we can draw the free body diagram, determine whether there is 2 force members or 3 force members, and apply the equilibrium of equations. Let's define that our orientation is the right hand direction is positive x-axis and the upper direction is positive y. Let's draw the idealized models. Point A, this is pin connected, and point C, this is also pin connected, and B, we have 4 kilonewton. Okay. Oh, let me see. There is a member. Since this is 1.5 meters, the angle here is automatically determined, which is 45 degrees. Okay. We know that point A is pin connected. There are 2 support reactions, which is x-axis direction and y-axis direction. AY, this is AX. We have 2 unknowns. How about this one? Member CD. Since this object is stable, then we have unknowns here, but they are same magnitude but opposite directions, and they are all acting on the same line, which means this is 2 force members. So force C, force D are the same magnitude but opposite directions, acting on the same line. Okay, let's solve the problem. First, let's choose the A, okay, because point A has many unknowns, so we can calculate the moment at point A. We don't need to consider these 2 unknown variables in the calculations. That makes our life easier. So for the fx, we have 1 unknown, which is ax. How about the others? Oh, okay, we have fc cosine 45. This one is equal to. How about the ay? For the y-axis, ay plus fc sine minus 4 is equal to 0. And sigma moment at point A, that means the 4 kilonewton create clockwise rotations, so which means minus 4 kilonewton times the perpendicular distance is 3 meters. How about the at point C? There is a vertical support reactions, which is fc sine 45. So is it it's counterclockwise. rotations, so positive. FC sine 45 times 1.5. So from the last equation, we can find that FC is equal to, wait a minute, what wrong is this? Okay, FC is equal to 11.32 kilonewton. Okay, since we have only one unknown and we have one equation, we can find FC here. Once we find FC, then we can plug this number into here, and here. So we can calculate that AX is equal to minus 8.0 kilonewton, and AY is equal to minus 4 kilonewton. Okay, so it seems like our assumptions for the support reaction, you can see the direction of these two support reaction is AX is for the positive right hand direction, is positive upward, but based on our calculation, we can realize that our assumption was wrong. So it should be the opposite directions. Here we have answers.